All right, guys. So we'll continue from Hive. Just quickly recap. We have seen what is Hive, how it is working as a data warehouse, from where they are managing this information. What is the pipeline? Like if I want to connect my module, where Hive is fitting in that data flow or in that data pipeline, and how to create internal external table, what all meta store we have, what is the data type in terms of standard, primitive, complex, then different meta store where they are keeping their metadata, where Hive data is getting stored, right? So this concept we have seen already. Then internal table and external table difference, why to create internal table, why to create external table. We'll see some other example today. So today is mainly on practical. We will only perform practical, and I'll start optimization part today. How we can optimize Hive query in terms of data or in terms of query using MapReduce execution engine, or if I want to change my execution engine from MapReduce to TZ. TZ is another tag scheduler which works with the in-memory concept. So we'll compare this MapReduce execution engine with TZ. Before that, we'll see some other example like creating table, then loading data, and then we'll run our optimization query on that table, which we'll be creating in Hive. So before moving to any other practical, I'll start creating database here. This is the command to open your Hive cell from command line terminal. And there was another option to open the same Hive with Hue editor. So that we have seen in the last session. Opening this browser, going to Hue editor and selecting that option, Hive editor option, then we are running the query. So that is based on in-memory. If you compare this execution time and Hue execution time, so Hue can take some extra time, okay, because they're heavy in terms of loading and where their query is getting submitted. So they're taking some RAM to run their query. Now, first I will create a database, and we'll create this database name as create database. I'll give 12 p.m. and we'll keep all our table inside this database. Use this 12 p.m. database, create table statement. So I have a PDF file. I'll follow this structure. Create table TXN records, transaction records. Since this is the first table, I'll write here. And when I share this file to you, okay, after the session, do not copy and paste. Please try writing. This is the only way to get more hands-on. So create table TXN records, and we'll define column name. Now this table is internal table because I'm not explicitly writing here term external. So now based on the application, we can create internal and external. Concept is known to us. So I'm creating internal table for this. Column name is TXN number. This is case insensitive. So if I type in uppercase integer or in lowercase, it won't make any difference. Second column is TXN date. Transaction date, you can keep a string also, okay, and you can keep timestamp also. You can keep data string also. So I'll use what is defined there. Customer number is integer. Amount is double. Category string. Product and city. Product is also string, city string, state and spend by. State is a string and spend by is also string. So these are my column names. Enter. Then other structure, row format delimited, fields terminated by. If you're loading a file and you know their delimiter, you can give the delimiter. My file is having comma. It's a CSV file, comma separated value. Lines terminated by no need to write because it will take automatically. And that's it. Semicolon. You can pass stored as which format you want to store. So Hive supports multiple format, which we'll see. Okay, not today, but when we have the file format session. By default, they'll store this data in text file. So currently you understand there is a one format, which is a by default format. And we call that format as a text file format. I'm giving that's okay. If I'm not giving, by default, it will take the same format, which is a text file format. Once you're done, show tables, always validate this. So txn record table is there. And then we can run this query txn records, how many column we have inside this table, then how many different storage we have, as in where this table will keep their data. So to get the broader detail, we use so create table and table name. What's my table name? It's a records. So intuitively, this is the same query as I used to run desk extended, describe extended, but this is giving me data in a proper format, right? Our table name is records. We can see now column name, what type they're using. Lazy simple study. This is one type of serialization deserialization. I will bring this concept of lazy. It's very important. Lazy is nowadays very popular in functional programming language like Python, Ruby. There is another functional programming language compiled by Java, which we call Groovy. Scala also use the same thing. So lazy is one term. We can note this. We'll discuss later. Field delimiter is comma. Serialization format is stored as input format. You can see by default input format is a text input format. Output format is a text output format. If I do not define this, so stored as text file, by default it will store in the same form again. Since this is an internal table, we know that all internal table data gets stored in this directory, user hive warehouse, right? This is my database name. So one folder is created in HDFS. This is my table name. There is another folder with the name txn records. This is the same, my table name. Now I want to load and transient last DDL. DDL is a data definition language time. So this is the timestamp based on my system. Now I want to load data in this table, right? So I have two options. Whenever I want to load or insert, there are two options. One is a load query and second is an insert query. Load query is good for bulk loading. Suppose I have 1 million data available in some file and size is big, right? And this is in file stored somewhere in local file system or maybe in HDFS file system. So I can directly load this file from local using load query to my Hive table. Load is not checking your schema, right? Because that's what we have seen in the difference between SQL and HQL, that Hive is a schema on read and SQL is a schema on write. So they are checking the schema while running the query. Load can do the job as soon as possible. Insert will take time because this is a intra-Hive communication, or this is a DML query, data manipulation query. So when I write insert into table name values, that's one DML, or this insert I'm doing from table 1 to table 2. So suppose this all the information is already available in some of the table, and I'm extracting that information or replicating this table information to another table, which is my table 2. In that case, this load will not help me. So I'll have to use this insert query. We'll see that all insert operation, how can we take few column, all column, uh, data based on the query or condition. Currently, I'm going to perform the loading operation. And queries as follows. Since my data is present in local and this is in my desktop, I've copied this using FTP software. So you people can use your WinSCP and copy this. You can try using drag and drop also option if you have shared directory. If not, WinSCP is one software to copy data from Windows to Cloudera. We know the communication. This is present in my desktop. So I'll go to desktop and see that file. So the file is txns.txt, transactional data, and this is the bytes in total size. Okay, so I want to load this file. I'll take the path home Cloudera desktop and the file name. What's the query? Load data local in path. We use this local because we're extracting data from local file system. And then we give absolute path home Cloudera desktop txns.txt into table name, and that table name is txn records. So one file size I can match. This is the same size. Total time taken by my CPU to write this information on my Hive table is 2.025 seconds, very less time. If I'm inserting this much record using some insert operation, this will take at least 2 minutes or 3 minutes. Now to validate this, can I run a query? Select a star from table name txn records, and I want to see top 10 result. So I'm using limit query. And by the way, guys, this is all whatever query I'm using, the condition or the keyword I'm using, this is very similar as SQL, right? What we have seen in structured query language. So limit is giving me top 10 result, which are from 0 to 9. So one thing is clear that we have loaded our data successfully in this table. The same information, if I want to check from Hue, I can open in this this editor, and I can check it from there also. Now, can I go and check in my HDFS directory this data is present or not? So this checking purpose was already done, but since we are again connecting after a long time, let's check again. ls user hive warehouse database name, which is 12pm.db / table name. This folder is present, and / I should have filed that txns.txt right here. So this is the file, and their metadata is also stored. If you want to validate that, open this terminal, go to MySQL root p. What is the database name for Hive? It's a meta store. So if you want to check, you can use so databases. I will directly go and use meta store. Table name is select star from tbls. This will display that table. TXN records at last and select star from columns.v2. Columns, let me see the word, columns.v2, sorry. Yeah. So this is the schema detail of my table from here to last. It is started from TXN number from here. Okay. Now, can I run other query? So data store part is done. Now I'll run this query. Select count star from table name. Select count star from TXN records. Now this TXN records, I'm running count query. Count is a DML operation. Okay, this count is a DML operation. So whatever data size I have in my system, okay, in this table, which is this file, in this directory, there's a txns.txt file. So when I run query on my table, which is txn records, this is going to scan the result, that txns.txt. This is the file. Suppose the file size, okay. Now here we need to know each query, how much time they're taking based on your mapper and reducer. Because if you do not know how many mapper or how many reducer your query is taking, you cannot optimize it. So how to check this mapper and reducer? By default, we have seen using the maprate.map.task and maprate.reduce.task. What is the by default mapper number and reducer number? That's 2 and 1. So by default is 2 and 1, but 2 mapper will only initiate when they are processing 2 different block. And each block size we know is 128 MB if they're fully occupied. If separately have copied two different file, then maybe one file size can be 10 KB also, and second file size can be 100 MB also, right? So to check the data, you can go to this directory. We have already went to this directory and seen this, that txn.txt file is present, which is obviously not more than 128 MB. So number of mapper which this query will generate, is going to be 1, because file is 1 and file size is less than 128 MB. And number of reducer will also be 1, right? Because this is the by default number. So mapper, they are taking 1 because of 1 block, and reducer also they will take 1. Now why they are taking reducer? In my previous case, when I'm doing insert operation, right? When you're running insert table name into values, your reducer is not invoking there, because insert query is not a aggregation query. This reducer will only start when you're doing this aggregation. Please make a note. Otherwise, it will not start. Since you are doing count star, and count star is scanning your record one by one like this. So if you have 50,000 rows, it will scan one by one, right? This is a row-oriented concept. There is another concept which is popular nowadays, and many of you heard about NoSQL. Not only structured query language like Cassandra, HBase, MongoDB, DynamoDB, OrientDB, all they do is scanning vertically. This is a vertical operation. SQL, RDBMS works like this, row-oriented. So this is, their performance is very less compared to vertical. We'll see this all the concept when we compare NoSQL and SQL. Okay, what is the internal behavior of this concept and what is the internal behavior of this? But for now, what is your takeaway? Any row-oriented query, okay, any row-oriented query or row scanning query is costly. It takes time. It's expensive operation in terms of CPU and their disk. Now let's submit this query, and immediately this will launch one MapReduce job with the number of mapper 1 and number of reducers should also be 1. We'll see. I can track my job from here. So just the way we did in a scoop, we can copy this and open this in browser and just paste here, enter. So this is the port number for your application master, 8088. This takes some time. Does Hive keep metadata about files or only table structure? Metadata about your table structure. File is present in HDFS. So metadata file is present with name node, Hatim, because name node is maintaining your all FS images and edit logs. So this query is currently running. That's why I'm getting this state as running state. Total number of mapper is 1. Total number of reducer is also 1 here. Okay. Let's see. The output is there. If I refresh it again, I'll see as completed. So we get the total row count as 50,000 with certain number of mapper and reducer. Now you see this is 100%, 100%, then 100%. What is this? What do we call this stage? 100% or 33% or 55%. So we know that CPU is taking this much time to complete this, but let me tell you this step first. If you see any mapper and reducer is giving you, you're seeing that mapper started with 0% and reducer also started with 0%. This is how your job gets started, right? Process is what? Again, your client is submitting the query, which goes to name node. If data is present in, because data node information is with name node only, then sorry, this query is first. Since this is a query thing, it is first going to resource manager. 8032 resource manager will communicate to name node. Name node will provide that data node information to resource manager. Then resource manager will submit to node manager, where I have my data node available. Once they are submitted, this node manager will launch one application master. This node manager will launch one application master, which is 8088, and then they start tracking the job. And this will give one job name, job underscore 502357 underscore 2985. Some unique name you'll get, some application name you'll get, and as soon as these jobs get submitted, they start giving you the percentage that mapper is done this much, reducer is done 0%. Now the question is, you see after some time, mapper is 33% done, reducer 0%. Mapper is 55% done, reducer is 17%. I'm just taking this number randomly. Okay. When you see this, what do we mean by this 33% and 55%? This mean your total data. Okay, this mean your total data of this job. Suppose this job is processing. So this client has run a query. This client has run a query, and that query is looking for. Suppose that query is this: select a star from TXN, table name is transaction, where we need to know all the transactions which are happening in city called Mumbai. So we have so many data set available in this transaction table. Remember, this transaction table is having a city such as Mumbai, Delhi, Hyderabad, Chennai, and so many other cities are there. wherever I have my business. So all the transaction information are getting stored in this transactions. Now we're only asking to check the record for data from Mumbai. That's my query, DRL. Now, first thing, what is the total size of this TXN table? How much information this TXN table is keeping? So let's say this TXN table is having total data 3.5 GB. This is the total data of this table, okay? And out of this 3.5 GB, Mumbai is having total 800 MB data, where city is Mumbai. So my query will run on this 800 MB data. First, they will scan the complete result, which is 3.5 GB. That's what we'll see, how to only run a query for Mumbai. Because currently what is happening, it is scanning this complete result. It is scanning this complete result, and after scanning, which is my first stage, second stage, they're filtering the result only for Mumbai. They're filtering this result only for Mumbai, which says there are total 800 MB result. So 800 MB result map task started. Now, if there are 800 MB total result, how many map tasks will be there? Total map task, if I want to run parallel task and I have enough number of CPU available in my system, this is going to be 128 MB, 128 MB, 128 MB, 128 MB. That gives me 5, 1, 2, 128 into 4. Then another 128 MB, which is 512, 128 is 0, 3, 0, 3, and 7, right? And last is 70 MB. So that's what I get. This is the number of tasks. Suppose I have total 2 CPU available in parallel. So this two tasks submitted first, right? This 2 tasks submitted first. Then after completion of this, again this 2 tasks submitted, and after completion of this 2 tasks submitted. So this will take a time because you are running 3 cycle. In first cycle, 2 tasks. Suppose they are taking X unit of time. Second cycle, again X unit of time. Third cycle, again X unit of time. That's what I'm calling a cumulative CPU time. Adding all this number is a cumulative. Individual number, if I add, I'll just say 1 cycle CPU time. So always your system will count the cumulative time for mapper and reducer. Now I want to focus on this point. What do I mean by 33% mapping done or 17% reducer is done, which means 33% of total 800 MB data has been processed by your mapper. 33% of 800 MB, can we do quick math? 800 MB into 33 by 100. That's what is 33%. And this is giving me 8 into 3 is 4, carry forward 2, 264 MB of 264 MB of data has been processed on map task. And where this output is stored, where your mapper output is stored, your mapper output is stored in intermediate location. And this intermediate, if you ask me, that's the local file system, right? This is on disk. This is on your disk, but not in HDFS. If I say reducer is 17% done, so whatever data is this, 17% of this information is written in HDFS because reducer will finally write their output to HDFS. So my Hadoop distributed file system will have 800 MB into 17 by 100, which is 6 carry forward 5, and this is giving me 13. So 136 MB of data is written in HDFS. This process is known as a data spilling. Remember, this is across platform. You have seen the same concept in MapReduce also, in Scoop also, in Hive also. So this process is known as a data spilling, which means that this amount of data is stored in local and this amount of data is stored in HDFS. Why this is important for your client or for your resource manager? Because we are saying Hadoop is working with a fault tolerant system. What do I mean by fault tolerant? If my query or my data fail in between, so suppose I run this query and when they're coordinating between mapper and reducer, any of the node goes down or any of the data is missing, which my mapper or reducer is maybe looking for. So this fault tolerancy option will provide me it will give me one provision to run the same query or take the same data from other machine. That's the reason we are replicating our data into multiple time, and that multiple time is 3. So again, I'm going back to our first very starting session where we have seen this all the feature of HDFS. What is the fault tolerancy? What's the replication factor? However, our focus is on this point, data spilling here. So how much data has been spillover on your disk? This is how, guys, you can calculate your total number of CPU, your total data, and how much task is required. Because when you are optimizing this, you'll have to create one CR. In production, I'm talking about change request you'll have to create. And this change request should have all that technical information written in form of technical task, which you are assigning to your admin team, Hadoop administrator. So you're not saying that please do research and development and use your own number of mapper and reducer. You'll do this by yourself, that how much data my project is about to accept per day, per week, per month, per year, and then you're giving this number. So scalability we are doing every now and then, just like monthly. It's not we create one structure for a year, then after 1 year we do the structuring part. So scalability is very important when you're working with a big data. It doesn't mean that you know how to create the cluster, you created the cluster, you started working with the scoop, and the job is done. This calculation make more sense. Coming back to the previous thing, so we know what is the mapper spillover, what is the reducer spillover, the total cumulative time, and this time is taken by just one CPU because I have one map task. So one CPU is taking this much time. Suppose I have two map tasks, then 2.95, and if I'm taking the same unit of time, 2.95 into 2, which will give me total 5.90 second, right? That's the cumulative time of mapper. And similarly for reducer, always your reducer takes more time because that's the aggregation query. After running this count operation, we'll go to see other operation like group by, and this group by is also aggregation, right? This group by is also aggregation. This will give me result. So people who know SQL, that's okay. People who are seeing this first time, I will explain in quick note what is the use of this group by. So group by is giving me output in form of key and value, always in key and value. Okay, so what query I'm giving, suppose there are total category. Let me take this 2 column. Since I'm running this query on this 2 column, I have a category and there is another column as amount. Okay, suppose I have category as I'll take a English letter A, B, A, C, A, C, D. Okay, I have this category and some amount is there, $200.00, $130, $500, $25, $19.99, $50, and $17. Some categories, some amount. When I run this query, categories, some amount from takes and records group by. What this group by is doing? This is converting my total result into key and value. The final result will look like this. It will say A. Now this A is a key. And what is the total aggregation on this A? Since I'm using one more sum operation. This sum is again aggregate query, right? So sum will add all the amount for A. So for A, if I check, this is A, and A. What's the total amount for this? 200 plus 500 plus 19.99. The value will come next to this key as 719.99, right? Second operation is going on B. So key is B now, and amount is for B just since we have 1. This will take less time. For second category, they will take less time because I'm not doing any sum here. I don't have much repetitive key for B. So this will populate as 130.00. The next is C. C is 25 and 501, which will give me 526.00. And last is D, right? So D is 17.0. That's how your result will come of this operation. So it's a key value. And this is expensive operation because I'm doing 2 times aggregation. I'm doing aggregation on amount also, and I'm doing aggregation on this category also. Whatever is the repeat, they will just add this. And remember, whenever you're working with a group concept or any key value concept, key can never be duplicated. That's the has function concept, which built early 90s. Has functions is used by many programming languages. Okay, this is like a whole one chapter. Now key can never be duplicated here. Key can never be duplicated. That's the concept of key and value. I'll go now and run this query. Sample you understand, and my result will come in the same form. But there I'm interested to know the number of mapper and reducer again, or how much time they're taking. So by the way, this information for that, we open this URL, and this URL is in this browser. If I refresh this again, I should get as a completed state. Let's wait for some time. Yeah, this is done, succeeded. You can see the state, time, and we know now how we can read the log file. The total time is 25 seconds. The CPU cumulative time is some 2 seconds, 2.595 seconds. This is for mapper. And log, I can check it from here. This is the full log file. So same way, just the way I did in scoop, the same way I'm doing, because internal operation is same for both MapReduce as execution engine. So whatever job you're running, please go open all the terminal and check every time. Second query is select category, comma sum amount from table name, which is txn records, and I'm running this operation on category. Enter. Watch the query, this log file. Okay, so we get the output. CPU and CPU time for mapper and reducer is almost same for two different stages, right? If you have question to a mean, or does this map task completes then only your reducer is starting, or it can be started in between also, like the example which I have given, 55% mapper and 17% reducer. So this can also be started, okay? Not always that after completion of 100% mapper only reducer is starting. There's a configuration for that. So I'll not recommend to go with this option. I'll recommend always once you complete the mapper, then only you start your reducer. Otherwise, your total time query will run, you'll get the output also, but performance will decrease. If you're saying after 50% of mapper, start the reducer, or after 30% of mapper, start the reducer. So there's one configuration point, which is a threshold. So we'll have to set the threshold there. So this is my result. Total air sports. What's the total amount on this? Second result, combat sports, second amount, and so on till last. So how many total category we are having? Total category is 15. I can check it from here. 15th row is the total result. Then select some amount from takes and records, group by customer number, limit 10. It will group by based on the customer number now. Earlier it was on category. This will be based on the customer number. And we are saying that limit the result for top 10. So same query. I'm just limiting this result for top 10. You can check this out. Let's go with the optimization side. So to optimize this performance or query, we have two options in Hive. Optimization. First option is a partitioning. So we partition the data, okay? And this partitioning concept is available in Oracle also. People who are working with latest version of Oracle, they know what partition is. If not, I will explain you. Second optimization part is bucketing. So this, using these two options, we can partition our data, and you can provide extra structure on the same data, which we refer as a bucketing. First, we'll focus on partitioning. Okay, so partitioning number one. What this partitioning does, here we have two types of partitions. First partition is a static partition. First partition is a static partition. Second partition is a dynamic partition. Okay, when to apply static partition and when to apply dynamic partition. So a static partition seldom, like if I'm doing 100 partitions, maybe one partition is a static. Most of the time you're doing the dynamic partition. I'll start with the static partition first. This is only applicable for data which are coming from one specific result. Specific result, when I say, suppose I have one file, and I'll refer the same transaction. Suppose I have one transaction file somewhere in the server, or in flat file, or in my local, or in HDFS. This file can present anywhere. Okay, and this transaction is size of total 500 GB. This transaction file is having total data 500 GB, and the result are as follows. So I have a transaction ID, I have a transaction amount, I have a transaction bank detail, on which bank the transaction is happening. Then I have their payment gateway type. I'll say payment gateway. whether it is a MasterCard or if it is a Visa, it's a first data. What's the gateway? And I have a city where this is happening. Suppose I have this many column. Now, static partition can only be applied. There's a limitation. Remember this limitation. Static partition can only be applied if all my result, okay, so transaction ID is 100, 101. I'll take some 5 example, 102. So 5 rows we have here, 103, 104. Amount is some 1300 bucks, 5000, 1800, 9000, 15,000. Bank is SBI, SBI, Axis, SDFC, Citibank, and some payment gateway. Okay, payment gateway I'll write as type 1, type 2, type 3. So type 1 is like banking transaction, type 2 is a digital wallet. So type 1, type 2, type 2. City, this is important. Suppose I'm partitioning my data. Okay, I'm partitioning my data based on some column, because this partition will apply on some column out of this. So txn is my table name, txn is my file name. This txn is stored in this is stored in local file system, and I want to create one table which is txn underscore new, and I want to load this file to my txn underscore new table. Now, if all the cities belonging to one name, let's say Dali for all, so this result, since this is 500 GB result, okay, if I use partitioning column, so in partitioning, I will hard code that this file is having all the city name as Delhi. Suppose I have another file which is transaction underscore one. This is having all the city which are Mumbai. And similarly, my TXN2, if I have already segregated my result, okay, in my local file system, or people who are giving me this data, or maybe RDBMS team, they have already segregated this data and they're giving me this result only for Delhi, only for Mumbai, only for Chennai. Then I can use the static partition. Let's understand the concept first. Anyway, I'm going to do practical after this. Okay, but what if I have result mixed in a file? So my case number 1 is saying I have separated my result of cities, one city result in one file, second city result in another file, and third city result in third file. Okay, if I have result stored in this txn underscore mixed file, suppose the file name is this, okay, or say hybrid txn underscore hy. This is having same 500 GB result, and I have my rest of the column is same, like txn ID, amount, bank, payment gateway. I'm focusing on the city because I want to do partition on that. So this is having result stored in single file which are from many other cities. Okay, many other cities. Now, if I want to use partitioning on this column, city column, then a static partition will not be the good option. Then dynamic partition will be the better option. So if you think in real time, when you are receiving any transactional detail or any banking detail or any logistics detail, what do you say? You received the data in specified cities only, or most of the time you see the mixed record in real transactional system? So obviously we get the data from the mixed city or mixed date or any other column wherever I'm applying this partitioning. So most of the time that is the reason we are working with the dynamic partition. Example we have seen. Now the same example I will try to replicate in the practical. We'll go to Hive cell, and syntax of static partition is what? Here for any partition, for any partitioning, the syntax is partitioned by. So just be with me for another 10-15 minutes, you'll get all the points. Partitioned by, and the column name, any column wherever I want to partition this data, and their data type, maybe a string or any other type. So this is the syntax. In table I will write this. I'll create one table, create table, and my table name is static or st partition. Then I want to give 3 columns, transaction ID, which is integer, transaction amount, which is double, and city. Now you want to apply partition on this city. So do not write this as a part of your main structure on the table. Give this 2 column, next enter, and then type partitioned by. Partitioned by column name, which is city column. Right, city column, space, data type, string, row format delimited, fields dominated by. This time I'm giving tab delimiter and enter. So partition table is created if you type so create table name. Use, will see what is the use of partitions, okay, how they can optimize our any query if I run any query on this table. So this is 2 column, takes an ID and amount, and this is the partitioned column. And if I have my data stored in local file system, so I create one data with below structure, cat txn and today's date, which is 23rd May .txt. File name is having tab delimiter, so 1000, transaction ID, amount is 199.00, and city is Pune 1001, amount is 389.00. This is again Pune 1002. So currently I'm taking one case that all the cities from all the city name is one only, 389.00. This is 4000.00. This is also Pune. Sample 5 result will have 150.00. There's also Pune. 1004 350 100. Same city. Control D. File will check txn. This file is created. Now I'll run a query on my Hive cell. That query is same load query. Load data local in path. Load data local in path. Table name. Path, file path, which is home Cloudera. I think I have created that in desktop. PWT, it's in home Cloudera only, and this is the file name. I'll copy to avoid the spelling mistake. Okay. Into table name, which is sta underscore part. Then partition, you have to write this extra keyword partition, and this partition is happening based on which column. It's a city column, so you type there column name is equal to, within single quote you will write the value on which city you want to use this partition. So I'm hard coding this to Pune, and check the spelling also. If there is a small case, there is a capital case, your data, well, the load will work, but however you will see null result when you check this. Can you see so partitions table name, which is sta underscore part. So partitions is a query to display the number of partitions in your data set. Now the benefit of this I will tell you before going to run any query. I said this result is having total count. Okay, here I have taken Delhi, that's the Pune, not a problem. Here my total data set is 500 GB of the transaction, right? And all the result belongs to there, which is Delhi. Then txn1 is having another set of file, and this volume is, let's say, 300 MB. 500 MB for first city, second city, and for Chennai we have some 950 MB. Okay, and all this file is separate. When I use this load concept one by one, load data local in path, and I will hard code that this city is equal to Pune at first query. Then in second query I'll say city is equal to Delhi. Then third query will say third city is equal to Chennai. In my HDFS, it will create a separate file. It will create a separate file on this directory. Earlier in my txn.txt, which will go and will validate both the thing. In my previous table, when I use load data local in path into table name, what happened there? My txn record, transaction record, is having one file which is txn.txt. Whatever is the size, let's say the size is 1300 MB. My data is not distributed here separately based on the city. All the results are stored in one file only. So if I run any query on this table, it is always going to scan. It is always going to scan this complete result, which is 1300 MB. And then based on your filter operation, it will scan the result which are required by your query, and then it will do the mapping and reducing. But first thing, they're scanning the complete result. If you're able to get my point. I'll show you this when the partition static partition thing is done. Now in my second case, what I'm doing, I am creating one static partition where I said state underscore part slash. This will not have just file like this. This will have ct is equal to Pune. Only result of Pune will be stored here. Suppose my total data size, if I count this, 500 GB I have taken, 500 GB, 300 MB, and 950. So it is having 500 GB, 300 MB, and 950 MB. Total this table is having how much result? 501 GB point. This is 1250, and if I'll subtract 1024 by this, so I get 622.226 GB. Okay, this is the total table size. But table, when I'm running a query to check the result only from one city, it is not scanning this complete result. It is scanning the result which are only available in that specific city. 500 GB, st underscore part, second partition name, city is equal to Delhi, which is having 300 MB, and third partition will be sta underscore part, city, and by CPU performance also I'll prove you the time. In one table I will create without partition, one table I will create with partition. We'll measure their CPU time. So Pune, Delhi, and the last one is Chennai. This is having total 950 MB. Okay. Now in earlier case, what was happening when I run a query on this table? This query is going and scanning the full table. This table is going and scanning the full table, which is having size of 3.5 GB. And then later it is filtering this 800 MB data. So unnecessary, you're looking for other input which are not required by this query, right? So why don't I directly go to this 800 MB and run my operation? So that partition will say you can do that using a static and dynamic partition. So now I'm running the same query. Select star from table name, which is st underscore part, where city is equal to Chennai. Now, what is happening? This table is having total result as 5.226 GB, but this Chennai is having just 950 MB data. It will not even touch this file and this file. It will just go and operate on this 950 MB file and start their mapper and reducer. So don't you think your query is optimized? How much time? Your query is optimized almost 1000 times in this case, because you're not running any task on this operation, 500 GB and 300 MB operation. This is outrightly discarded. So 950 MB, again using the 128 MB concept, number of mapper it will create how much? I guess total mapper will be 8 or 9 mapper. You can divide this by 128, you will get the number, and reducer based on the set by your Hive cell. They will initiate that many of scheduler. But again, my requirement is very different here, that to perform the static partition, I should have this file available with me. Then only I can do this, because I'm separately storing this information, just like the way I did here for load data local in path file name into table name city equal to Pune. Suppose I have another file. just example, I have another file as cat underscore txn underscore 23rd May 1 underscore 1 dot txt, and I have here 100 1500, then 120. I'll just take this to example, 1700 Chennai. Now I load this data separately. Load query again. File name I've changed, and this city is now different city. Enter. If you run this query, so partitions table name, this will give you two partitions. One for city Chennai, second for Pune. Can we go to their HDFS directory and see how data is physically distributed? So open a terminal, HDFS DFS -ls test, enter. And I want to see the result for, you can see this. They are separated by their partitions column name. Now, if I'm running a query for any one specific city, I can see only result from one city. Now, can I apply this partitions on any other column? I can do that. Can I apply partitions on more than one column? I can do that also. Okay. So in production, what we do, we apply partitions mainly on date column. So since we are receiving data in daily basis, let's say my total data storage on daily basis is some 300 GB. Okay. Every day I store data 300 GB. So I will perform partitioning on my date column. So I have some date, let's say account open date. So people are coming to bank asking to open the account, and total data which are coming every day to my system is 300 GB. If I perform partitioning on this date column, then my separate date will have 300 GB data stored in their file system. So if I'm running any query in where condition, I will give this date, the date which I'm looking for. So it will not go and run and check the whole data which are available in your table. It will just check for that specific date and bring the result on your console. So suppose if daily you are doing this, and in a single month, how much data you are having. This is daily result, which runs from first any month of first date to last 30th of that month. So 30 into this, 300 GB into 30. Always do this math to clear the concept. 3 into 3 is 9, and this is giving me 9000 GB. This is the total table data. So one table is having this data. Now, since I'm working in a data warehouse management, which is Hive has said, are saying that why you are running query on all this table. Let's optimize this and give one column name as a date column and store result, everyday result on separate file or separate folder, because this is a folder, right? Can you check this? City is equal to Chennai. This is a folder. This is a directory. This is a directory. Inside that, I have my result. I'll show you that what result I'm having there. Okay. So if I'm running a query, I hope that's clear now. This query is only going to check the result from one specific folder. So my query is optimized how many times? Earlier it was scanning the result of 9000 GB, and currently it is dividing this 9000 GB by by this. So almost I have 30 times increased my performance. If I take this example, I've increased my performance 30 times. That's my observation. So question, we have some, what happened? We execute load data query without partition clause on a partition table. Okay, I'll do that. So I hope this is clear, and let's just verify, then we'll see the experiment which you're asking. City is equal to Chennai. I'll see the file, that file only. And this is the result which are only holding. Let me check this also. txn 23rd May underscore 1.txt. So this is only holding the last two entry, and this is having all the entry from the city. Okay, so how query will work, I think that's clear. How folder is created. Now, as many number of city you are having, it will start creating that many folder for you. Okay, so number of city is equal to number of folder you will get here. City I'm just taking, guys, as example. Not necessary that you'll have to take city only. You can take any other column. You have to be logical when you are partitioning. So always think which query which query you're running on regular basis, and how can you optimize that query. So if you're running a query and it is taking some time, so you can do this trial and test. It's not like one way answer. I do something and I get the answer. This is always, we are doing this in development environment. We are testing it first, we are checking the scenario, and once everything is satisfied, then we are moving this concept or this schema structure to the production table, not directly to production. This is all testing that done in the local space first. So now we'll go and see the experiment. So the question is coming as, if I load this file without partition, what will happen? Okay, suppose I do not write this, I directly write this. You get the exception, Hatim? Need to specify, because this is the partition table. This is the partition table. You'll get exception. Need to specify partition column because the destination table is partition table. Clearly mentioning that. So this loading, by default loading will not work if you not specify the city name here. You'll have to specify city name with partition syntax. Second thing. So we know now all the file, if they are well separated in individual file, we have individual city, can be handled. Okay, can be managed so well. But what if in the case I have a result like this? So I'll merge this result. Okay, I'll open this file. Let me copy this 2-line and I'll add this information in single file, 23rd May.txt. And people make such mistake, so thought to explain you this also. Whenever you're working, always check your delimiter is good, everything is fine, save the file and remove that txn which is not required by our query now. So my file is this txn 23rd. This is the file which is having mixed city. I'll try to load in the same table, and that table is here. My query is same, but this is asking me to provide the name of the city. Now, what do you think? Should I write Pune or should I write Chennai? I have mixed city available there, right? And this is the problem here. If I write Pune, and I'll use here overwrite because I want to delete my previous result. So whatever data is present, I want to delete that result, and then want to store this new file using the city name Pune. Table is loaded. It won't give me any issue because I have matched all the schema, and Hive is a schema on read. So loading is done, and file is loaded well in HDFS also. But if I run a query, select star from table name, select star from stay part, enter. One second. Let me overwrite this again. I will check this first. Stay underscore part. So this is present already. I will remove this entry. Or can I truncate the table? Truncate table name. And now I'll check this. Do we have any entry on this? City is equal to, sorry, this is for city. And this is second city. Now I'm loading this with this operation and select a star from table name. Yeah. See the result. You have total 6 entry here. Okay, in your file. In this file, you have total 6 entries, but 7 entries, 5 entries from one city and 2 entries from other city. But here you are seeing all the 7 rows coming from the single city. So data is not changed, guys. If you're thinking, how come my data changed from Chennai to Pune? Data is not changed actually. In Hive, they are keeping this metadata as Pune because you have passed this name here. City is equal to Pune. So all the data which you're storing will have this result. If I go and see in my HDFS, so this is just I'm doing as a part of testing. Pune will have that result, and all the result is right as local. If I check this result using cat command, I can see proper 5 result from Pune to for Chennai in HDFS. Nothing has changed here. And if I check my second folder, which is first city, this does not have anything. So we did this as a part of testing, but I'll not recommend you at first place to run this operation when you have record mixed from multiple cities. Okay, so static partition is strictly, remember, you can make a note somewhere that you will only apply this when you have a separate file and any specific column is having a result like this. Suppose if I'm taking example of city, it's only Pune. If I'm taking example of country, it should be only one country. Whatever country is this, if it is India, it should be India, India, and India, only India, at least for one file. If I'm dealing with amount, it should be only having one amount, $300, $300, $300. $300. So this is the requirement for static partition. Okay. Now, can I can I do insert approach here? So static partition, one option is done. The using load command we have seen, but now I'm going to perform intra-hive communication. I'm going to perform intra-hive communication. And what is the intra-hive communication? Within hive, right? Inter-hive, if I say I'm communicating from other module to hive, intra-hive is within hive. So we know that inter and introvert. I have one table. Let me call this as a table 1. And this is a non-partition table. This is a non-partitioned table. Okay, I have so many results here stored in this table. And I have one partition table. So static partition can be good with one kind of sampling also. Okay, we'll see that sampling. So I have another table as partition table. That's my table 2. Precisely, this is my TXN records table. So let me take that table, which is non-partition table, right? And how do I know it is a non-partition table or not? Using the so create table name. You'll see partition by. If you're seeing partition by, it's a partition table. If you're not seeing partition by, it's a non-partition table. And I will create one new table here with the name txn underscore part. Okay. I will create this one new table with some column. So I will see in my txn records, so tables, and first I will let me drop this step part. I don't need this table now. So tables, txn records is there. So desk txn records. I have txn number, txn date, customer number, amount, category, product, city, state, spent by. Okay. So spent by, we have some credit or saving. Let me see the result. I don't remember. So I'll run a query. Select a star from txn records limit 10. Do we have all the record only credit? How can I check this? Using the distinct query, right? Or group by. So I'll say select credit, select credit, comma. I want to sum the amount for specific credit from txn records, group by credit. I'm running this query just to check. I'm sorry, this is spent by. The column name is spent by. I was running query on the record. This is last column name, spent by. Okay, spent by. So I'm running this query just to check how many result we have in spent by. Is it just credit or we have some other result also? So we have cash and credit. Okay, credit is more, so I want to store some result for cash. Let's say result for only cash data. Now, how can I do that? I will write. I'll create one table first. Create table name, which is txn underscore part, and then column name. I will keep transaction number, their amount, and their spent by. Okay, transaction number, txn number, integer, amount double, and last column is anyway my partition column. Partitioned by, spent by, string, enter, fields terminated by. How you want to store your data? I want to store in pipe format this time, and that's it. Sorry, row format delimited. I forgot. Row format delimited. Fields terminated by pipe. So create table name. So this is my table. Now I will insert result on this table. So insert override table. And where you want to write txn underscore part. Okay, txn underscore part. Select from where? Select a dot is my alias of table txn records. Okay, because I don't want to get all the results, so I cannot use a star. If you're getting me, star if I'm using, so my txn record, whatever number of column I'm having in that txn records, I should have the same number of column here also, which is not the case. So I'll only need this the record which I want to write from txn record. So I'll say a dot txn number. This is how we use alias. A dot amount from a dot amount from, and by the way, I want to store a credit also. So a dot spent by, this is the column name, from table, which is txn records, where spent by is equal to only cash. So I have a big table, and from that big table I want to store this result only on my one table. And there is one syntax. Let me see that syntax. I have to define one partition keyword. If it is insert query, yeah, I want to save this partition. Select txn part, partition, within bracket, spent by, spent by is equal to cash. And if I'm giving this, then I try to remove this where condition. Invalid table alias. Okay, so alias I have not given. I'll give alias also. But query has 3 column. Let me see the error. Takes in partition. I'll try to give air condition a dot credit or spent by is equal to cash. Line 1 cannot insert into target table because column number types are different. Table clause has 2 column, but query is 3 column. Yeah. So let's see the output. If output is working, I'll tell you this query. Let's save this query somewhere. So my expectation is this should only store cache result from TXN records, like sampling, data sampling. So result is stored. We have some result also. Now validate TXN underscore part from part. Limit is equal to 10. Perfect. So all the result is there. Can I see how many total result are there? 6,849 total result we extracted. We inserted from that table. So this is what is the intra-hive communication. And why earlier it was not working? Because the query which I submitted here, I was passing 3 column here. Okay. And since I have already mentioned the partition column name, so I should not write this here. This is taking from this query itself directly. So that was the error, and I get to know the error because that said total number of column you're giving 3 and it needs just 2. So from there I get to know the problem. So you should know the error also, how to read the error. Anyway, out of 50,000 result from TXN records, so if I represent this graphically, TXN records, this table is having total 50,000 result, and from there we have extracted TXN part, and how many result we have extracted only from there to here, or inserted from one table to table 2, which is non-partition table, non-partition table, partition table. This is 6,849, and you can do n number of query. If you want to run only for one city, okay, this result I'm having mainly from US. So suppose you want to store data from Long Beach, you can keep this data only. You can create one table, give the name of city. If you want to store one category, specific category from this, you can play with this. So you have one table which you can say as a master table, and then you are creating a small table and writing only those information which are important. Or if you want to make partition in this table itself, so that option is a dynamic partition. If you want to make partition on the table itself instead of doing this bits and pieces, you can do dynamic partition. We'll see this dynamic partition, how useful this is. But currently, what did we see? One load option and one insert option. Insert is mainly your one table to second table. We can refer it as an intra-hive communication. Expensive query is always the insert one because they are DML. Load is not expensive operation, but we have many limitations, especially in the partition table if you're loading it. That's pretty much about your static partition. Now some information we'll say about, and yeah, by the way, if you want to check this all, I'll recommend you all do one thing. Take this table, or uh, I'll share this information, okay, the file name. What you can do, or if you're getting any record, or maybe you have any information already with you, so try to manage that in Hive without partition table. So create one non-partition table. So this is your practice. Those who are interested, please do that. Non-partition table. Okay, create here one table and run some query. Check some where condition and run a query, or run operation that group by category or something, and create one partition table. Create one partition table and run this operation. Anyway, I'm going to tell you tomorrow, but today if you get chance, you can practice. This is one table. I'm running the same query here, and I'm running the same query here. This query, if taking 100 seconds, based on my CPU and availability, this will be definitely much faster than this. So if it is 100 seconds, I can say this will take 45 seconds. So this is what is optimization query using a partition concept. Now for dynamic partition, okay, for dynamic partition, just brief I'll tell you. Practical will start tomorrow. Dynamic partition. Here, if I have result, mixed result, right? 1 city, 10 city, 1000 city, I can do that using this dynamic partition. Now, this dynamic partition need few properties to set in cell. So in Hive cell, we'll have to run some property, and that property name is there. So these are your property names. We have this 3 property to set in our Hive cell. First, Hive exe, and this I'm running on Hive cell. Remember, this all query I'm running on Hive cell. Hive exe.dynamic.partition.mode. By default, this is set as strict mode. By default, this is set as a strict mode. So if you want to check that what is the by default value, you can write till this part and use a semicolon as a statement termination. Once you write this, you will see the option. Okay, can we try this in my system? Set hive.exec dot dynamic dot partition dot mode. This is by default set as strict, which means only this is allowed for static partition. If I want to give access for dynamic partition also, I'll have to change this strict to non-strict. Give this value and semicolon. Hive execution dynamic partition you'll have to set as true, because this is also by default set as false. So you change it to true. Bucketing will see this. This part we'll see later. Not right time to discuss. If I make this 2 partitions active in my system, then this partition will work. The dynamic partition will work. Syntax is not different for dynamic partition. Okay, syntax will be similar. I'll say create table, table name, whatever column I want to define, and then partition by. Partition by column name, same as static partition. Only the agenda is different. Only the requirement or the application is different in static and dynamic. Not the concept is different. Concept is exactly same. So partition by column name, then row format delimited, row format delimited. Next, fields terminated by. And if you want to create external table, okay, if you're thinking why I'm not creating external table, I can create external. Okay, just since the query is written as internal, I'm writing it. But if you want to create by yourself external, you can do that. No problem with that. Fields terminated terminated by whatever field termination you want to give, and that's it. Once this is done, now in dynamic partition, let me write one note, last note for today. Load operation will not work here. Load operation will, or I'll change my statement. Dynamic partition does not support load operation, which means earlier you were doing load table name partition and then some hard coded value. Now that is only allowed in the static partition. That load statement is only allowed here. If I want to do, okay, if I want to communicate from one table to another table, and dynamic partition only work with one approach. Dynamic partition support only table to table communication, which is an intra-hive communication. So it's a table to table communication when one non-partition table, right? One non-partition table, and have some table name, have big table for tomorrow, and second is a partition table. So I'm taking the exact same record. I'm taking all the result from here, exact same data in this partition table, because if I'm running query on this, it is taking time. In production, if you ask me how much time, personal experience, some query has taken I guess 84 minutes also. So you can assume that 84-minute query, then what is the use of big data? Then how my cluster is not optimized so well, right? So since this were all earlier issues that they are taking more time, because if you go to early days of Hive like 2015, 14, we did not have so many properties. Nowadays Hive is very, very popular, so fast, and not just Hadoop companies are using for warehousing purpose, many other companies are also using, right? Now, if this query is taking some time here, X unit of time, and this unit is in microsecond, I want to convert this into nanosecond or picosecond or femtosecond or autosecond, any list unit, okay, any fraction of second. The more you go, the more better is my performance. So non-partition table to partition table, only this operation you can do with dynamic partition. However, if you think you have 180 which are coming from one name only, you can use the static partition using the load operation. Dynamic partition table creations and other operations will start tomorrow.